And last but not least, Sara Behjati. Hi, Sara.
Hi.
So your thesis title is Designing DNA-Wrapped Single-Walled Carbon Nanotube Optical Biosensors for Cancer Biomarker Detection. That takes 180 seconds to tell just the title, so you're lucky you don't have to read it. Laboratory of Nanobiotechnology. That's where you're working with Professor Artemis Bogossian. Are you ready?
Yeah, I'm super excited.
Yes, great. That's a good start. So let's enjoy for 180 seconds.
Of course. Light. It is one of the most convenient ways of communication. To get messages visually by light, we don't need to have attached wires to us or Wi-Fi connection. And it is fast. We just walk in the street, look at the traffic light, and we stop when it is red. Humans have been using light to communicate with each other from thousands of years ago until now. But can we use light to communicate with our own body? To understand what is going on deeper and deeper in our cells? To recognize cancer cells from healthy ones? And to find out how they work? To communicate with cells in this way, we need to make them bright and shiny, like this traffic light. I know, now probably you are wondering how to make cells bright. Yeah, of course, our cells, they don't emit light by themselves. Otherwise, we all would be walking, shining human beings, illuminating everywhere around us and solving energy crisis, at least for the lightening part. Now, to brighten the cells, we get help from a specific synthetic material, carbon nanotubes. They are tubes, but 100,000 times thinner than our hair. Imagine how small they are. To make these nanotubes harmless to cells, we dissolve them in water. And now, because they are harmless and super small, cells will take them up. These nanotubes emit light inside the cells, and we see the cells bright. Perfect. Now we have our shining, bright cells. But how does this brightening help us to recognize cancer cells? Here is the point. The chemicals inside cancer cells are different from healthy ones. In my PhD thesis, I engineered these nanotubes to be sensitive to the chemicals inside cancer cells, to see them brighter. Actually, that's how we see this red light coming from a bunch of cells. We use this red light to communicate with our body, to get its alarms and the messages. More red light, more cancer cells. Isn't that great? And when this red light of cancer appears, we stop. We look at the cells, we monitor them, and we gather information to fight against cancer and bring safe, green light of life back to people. Let's hope for that day.